Welcome to my solution of the binary search, the recursive binary search practice problem. So let me reset the timer, 15 minutes. So I need to implement the performs a binary search for value in the sorted array data. Return the index of value in data or -1 if not found. And there are two parameters. Data, the sorted array, and param value, the int to search for. Okay. Public static int binary search int data int value. Now I want to use a recursive method here to simplify this, and that implies that I need to pass in some additional parameters for this method. I don't have enough information that's being passed in recursively to keep track of what section of the array I'm going to sort. So I will just simply say, I'll make my recursive method here, public recursive helper method, and it's not public, it's private. Int, it returns the int recursive binary search. I need to pass in the int array data, int value, what I'm searching for, int start, int end. Now these two ints, so let's define these at param data, the sorted array, at param value, the int we're searching for, at param start, the start index, at param and the end index. So we're only going to consider the array, data array, from start to end. So we can go back up to our thing and say return recursive binary search data value. Where do we start? We start at 0 and data dot length -1, because we don't want to search beyond the end of the array. So now we're going to call the recursive method. And so how do we use the recursive? We're going to consider, is the middle of the thing the value? So int middle equals start plus end plus end divide by 2. So that's going to be the middle index of the array that we're considering. And so we want to say if value is less than data sub middle. So that means the value is actually in the left-hand side of the array. So we would then search the left-hand side, so then we recursive binary search, same data array, same value, but now we want the left-hand side, so we go start to middle -1. Now we -1 because we checked the middle one, so we know that's not the answer. So now else if value is greater than data sub middle, that means it's on the right hand side. So we want to search the right hand side. So recursive binary search data, we're still looking for value. But now what the start thing would be middle plus 1, because we search middle, and end. So now that's going to do the right, search the right hand side. Now, if it's not less than and it's not greater than, then it's equal. Return middle. We found it. Now, if we get through the end of this and we haven't returned, I'm going to return this. Return this result of that. Return the result of searching the left-hand side. Return the result of searching the right-hand side. Or we sit it. Now, if we get down to here, we didn't find no, I'm sorry, yes. Forgot my base case. I need to do my base case. If start is greater than end, my base case return -1. So if I'm saying I'm searching from start to end and they've swapped over, that means I've searched everything and I did not find the answer, so I want to return -1. I want to return that before I start my recursion again. So back again. So we're going to say we're going to start from 0, but eventually middle might be start, and then so start will be greater than end. Same thing here. This will be greater than end if we're looking at the same spot. And so then we need to say if start is greater than end, or we could even say, well, greater than, because if it's equal, it might be in middle. It might be at that spot. So we'll say greater than. And so if we're trying to search for in the array and we've searched for everything, then we didn't find it, so we return -1. We then calculate the middle of the array. We then see if the value is on the left side or is less than middle, which means it would be in the left-hand side of the array. So we return searching the left-hand side. So searching from start to middle -1, which would be the left-hand side. If it's greater than middle, the value is greater than the value at middle, we want to return the result of searching the right-hand side. And again, middle +1, and the end, that's the right-hand side. And if it's equal, then we found it, and we want to return the index, which is middle. So now that's the code. So what's the big O? Big O of the binary search? Well, we're dividing the size of the array in half. So the size of the array is n, so we divide by half each time. So that is basically log base 2 of n. And again, it's log base 2, but 2 is just a coefficient, so we drop it. So the big O is log of n. So we keep doing the divide by 2, which is a logarithm. And so it's log of n. And if I wanted to, log of n, or I could just say log n. So again, we use a recursive helper method. I can't use the binary search method as my method because it just doesn't have enough information in the parameter list. So I needed to add the start and end to say what part of the array I'm considering in each of my recursive calls. So then I see, have I just decided there's no more of the array, in which case we didn't find it. Then we calculate the middle, we check the middle, decide which, do we search left or do we search right? And we search left and right by calling the recursive method again and again. And if it's not less than, it's not greater than, then we are looking at the item, and so we return the index. And because we divide the array in half each time, it is log, the big O is a log of n. Thank you very much for your attention.